So this video is just to help you see the way we would construct certain transformations to prepare for our upcoming quest. So if we look at review 1, we're going to go scroll down. So review packet 1, if we look to, let's see, our first question that we have to construct with, our first construction would take place on question 6. So when we went through this in class, given the regular pentagon ABCDE shown below the center of F, answer the following questions. A, what is the minimum angle needed to map B onto E using a counterclockwise rotation about F? Show how you arrived at your answer. Remember that the maximum amount you can ever rotate a shape is 360 degrees. Since we're going through the center of the shape, if it's a regular polygon, you can always divide by the number of sides. Regular meaning that all sides are congruent. Examples include an equilateral triangle and a square. Every other shape will be known as a regular blank, like in this case a regular pentagon. All 5 sides are congruent. To figure out the exact angle, take 360, divide by 5, we would get 72. Now keep in mind, to go from B to E, that would take 2 rotations. So 72 times 2 is 144. 180 degrees would not be a rotation about F that would land and make symmetry. It wouldn't land or coincide on each other because 180 is just not a multiple of 72. So in this case, it does not work. Now the purpose of this video is to kind of go through constructions. So part C says construct the line of symmetry that would have to pass through A. So remember, a line of symmetry is also known as a line of reflection. It cuts everything in half the same way a line of reflection would do. So A would not only just pass through A, but it's also going to bisect DC as well as pass through F, the center. So when we look at that, any perpendicular bisector, we go at least halfway and make our arcs from one point, and then we pick up without changing the length of the compass from the other arc. We have 2 intersections. Once we have 2 intersections, we just draw the straight line that passes through both intersections. And you'll see that it passes through both F and A as well. I'm just going to move over here so it passes through a little nicer. But our line of symmetry is made by a perpendicular bisector. Remember, our perpendicular bisector is one of the more popular transformation constructions that we're going to see throughout this video. If we look, there's no constructions on the next page. Now for 9, just like we saw a line of symmetry as a perpendicular bisector, a line of reflection is also going to be a perpendicular bisector. Only thing you have to do to start. First, we should notice the order of the points, such as triangle DEF and ABC. Remember that points coincide on one another, like D and A are going to map onto each other, like E and B would, and F and C. First thing you should do is connect any of the corresponding points to one another. I like to use a dashed line when I'm doing this. If you use the regular straight line, you're fine. And picking any of those points is fine. On your page, using C and F might be a little small to get the whole construction to come through. If you have that issue, that's okay. You can be bigger than the line. But I'm going to go with B and E just to make it a little bit more convenient for us. But our construction, a same exact thing that we saw on the last one, perpendicular bisector. We start at B, more than halfway, make an arc, pick up your compass, put the point at E, and use the same length. Notice I did not change the length of my compass size at all. I only go from a new point, but we draw the line that connects through, and yours would be a little bit straighter. Usually line up your straight edge, and to be totally safe, we're going to add arrows just because a line of reflection goes on forever. But essentially it's the same as our line of reflection. Okay. One more construction to look at is in here, we're looking at A prime and B prime is the image of AB after a rotation about some unknown point C. Draw in a segment B prime to B, excuse me. I'm going to use the dashed line again just so to avoid confusion with the line segments. If you draw a straight line, that's totally fine. Now I want to construct its perpendicular bisector. So I'm going to just go to the top of our page and bring down our compass. Now, when we go through with this, from B or B prime, you could start at either point. We're constructing the perpendicular bisector between those 2 points. So remember, more than halfway, you can extend to any length. Now, if yours is smaller or bigger than mine, that is totally fine, as long as when you're done, you end up with two intersections, one above and one below. Now, with that being said, we have an intersection above and below our line segment. So we're going to take our straight edge and line it up so that it passes through both intersections. Now the next question B says, explain why the center of rotation C would have to line on the perpendicular bisector that we just constructed. The reason this occurs is because every time you construct a center of rotation, you actually need to construct the perpendicular bisector twice. So we do it from one point like we just did from B prime to B. We're going to do it again because part C is going to ask us to find that location anyway. So and I'm just going to delete that real quick and use a dashed line just so I don't confuse my lines at the end. Again, if you do straight or dash, it's fine. Just use some kind of highlighting or numbering method to try to not get yourself confused. But I've now connected 2 different points. So we started with B prime and B. Now we have A and A prime connected. Same construction, only focusing on that line. We're going to do another perpendicular bisector. We can keep the same length. We can stretch bigger or shorter as long as it's more than halfway. We make our arcs above and below from A. Repeat the same length of our compass from A prime. Again, our major goal here is to get 2 perpendicular bisectors. We already have the one, so now our intersection above and below, we connect with a straight line like so. I'll straighten out my line a little bit. Yours probably won't have this issue. But our center of rotation is where those 2 lines intersect. Our center of rotation in this case is right here. We're going to label it as C. That's where the center of rotation occurs. To find a center of rotation, we always construct the perpendicular bisector at least twice. You could go further if there was more points to connect. In this case, we don't have that option. But if you had one with more points, you could go further, but it's just creating more work for yourself. You just need 2. But part B to explain it is just that we need 2 to find out where the 2 perpendicular bisectors meet, so point C. Just kind of switching gears to our our second review sheet. Remember, the perpendicular bisector is probably the most important construction you know for our quest. Anytime you construct a perpendicular bisector, we start at either endpoint, go more than halfway, whether it's the full length, whether it's shorter or longer, as long as you have an arc that extends above and below your line segment. Without changing the length of our compass, we go to the other endpoint and make the same arc above and below. Once you have that, take your straight edge, connect straight down, and mine's slightly off, so I'm going to straighten my line out a little bit. And we have a perpendicular bisector. Remember that perpendicular bisector also could get us the midpoint. If you were asking to find the midpoint, we would label it right here. Along the line AB where it gets cut in half, that would be our midpoint. Remember, constructing the line of reflection, same exact construction, only we connect any point whichever point we choose to connect, say we connected these two, just take the perpendicular bisector, the same tool we used here, and we saw a perpendicular bisector earlier. In 3, construct the center of rotation. Remember, constructing the center of rotation is exactly the same as the perpendicular bisector, only you do it twice. So you could pick any of the corresponding points to one another, such as A to A prime, F to F prime, any one you so choose to use. So if I connected F and F prime here, we would take the perpendicular bisector of those two segments. So start at one of the segments, extend more than halfway, whatever we so have, do the same thing. Oops, let me undo that real quick. Same thing from the other point. And we would connect our perpendicular bisector. I'm just going to make it a solid line so we know the difference between our lines when we're looking for our intersection. So we have one perpendicular bisector. Remember, the only difference in a perpendicular or a center, constructing the center of rotation, is we do it from another point now as well. You can choose whatever point you want to use, whether it be A, B, C, D, or E. So if I connected B to B prime, let's say, and cut that one in half, so perpendicular bisector, as long as we're more than halfway. Now I know it's going to be harder when you don't have color, so you can feel free to use a highlighter or a colored pencil, anything, even if you have a numbering technique, like if you labeled 1, 2, just so you can follow the path as much as possible. But when I connect that straight line through, I look for where the two lines intersected. So those two lines intersected right here, and that's our center, and usually you'll be told to label it as a certain letter. Now, a nicer construction that we'll probably like a little bit more. For 4 here, it says construct a 180-degree rotation of the segment AB about point A. We are going to always start at whatever they say the center of our rotation is. So clear part of your compass at A. Have that same amount to B. Now 180 degrees we know is a bigger arc, so at least 180 degrees is at least half a circle. All we have to do for this construction now, start at B, extend through A, until we can label in our B prime here. So our construction of a line segment, when the center is on that line, just extend to a straight line or a longer straight line, however you'd like to write that. However, in 5, when we do this construction, we take our center. Our center is always where the clear piece starts. So we start P, and you pick either C or D to stretch to first. Oops. We'll stretch out to C, and if you did D first, no worries. Well, we go counterclockwise. Remember, we're going more than halfway. Same idea though, from C through P. This is going to be our C prime. Same motion now, just a new point. We always start with P as our center. We're going to stretch in. Oops, I'm going to fix that. Stretch our compass into D, counterclockwise, more than halfway. If you want to make a full circle, that's fine too. From D through P, that's our D prime, and connect to finish.